results and data sets. Today I am going to tell about traveling salesperson problem using dynamic programming in ADS. Before you should mention the traveling problem. Traveling salesperson program is mainly based on dynamic array, dynamic programming. It's mainly on bit marking. It is the optimization problem. For example, if a salesperson have to travel different cities from now minimizing the total distance what she had to travel. This is about traveling salesperson using dynamic programming. Before that, I can make a small example related to this. Take a adjacency matrix like considered as rows and columns. Here we should have to solve this problem. We should mention this formula. This is the main formula to solve the problem. This is the rows and this is the columns. Here this is the formula to solve the problem of dynamic programming. And here see, take an example of nodes. This is the example related to this question. Consider the elements by modulus. Mod S. Consider the elements like mod S. If see, mod X is equal to 0. Consider mod S is equal to 0. Here, 0 is considered as 5 in this problem. For example, G of 3, 5. In the row, third row, 3, 5 is considered as 6. And G of 2, 5 is considered as 5. G of 4, 5 is considered 8. Mod S is equal to 0 is considered. Now consider with mod S is equal to 1. Here mod S is equal to 1. How many nodes are connected to the mod S1? 2, 3 and 4. Again 2 is connected to 3 and 2 is connected to 4. So this is the parent node which is these are the child node. So mod S is equal to 1. So consider based on the formula you should have to solve this problem. So here consider I is equal to 2, J is equal to 3. And here I mentioned here J belongs to S. So J belongs to S means both J and S are same element. So G of I is equal to 2. S is equal to J and S are same elements. So 3. C I is equal to 2. J is equal to 3. And G of I is equal to 2 and S is equal to 3 and minus J. Here column row to column 3. This is the row and this is the column. Row to column 3 is 9. So you should have to mention C to 3 is equal to 9 plus Z of here 3 minus is 0. So 2, 5. In the question they had mentioned G of 2, 5 is equal to 5. So minimum value G of 2, 5 is equal to 5 now. So 9 plus 5. Here minimum value is equal to 14 for G of 2, 3. Like that, here 2 is connected to 3. So here g of 2 comma 3, and again you have to find for g of 2 comma 4 and g of 2 comma 2, 3 comma 2 and g of 3 comma 4, and again for g of 4 comma 2 and g of 4 comma 3. Like that, step by step you have to solve this problem like this, but based on formula. And like this mod s1 is equal to completed, and based on mod s is equal to 2. Here how 2 is considered as 2 nodes. Here 2 has 2 nodes. Yes or no? 2 is the parent node and 3 and 4 are the child node. So you are considering 2 children. So you should have to mention g of 2, 3 comma 4 is equal to, here I is equal to 2, j is equal to 3 comma 4. Based on this, you should have to substitute in this formula. Min value is equal to, see, here I mentioned 2 and j 3 comma 4. Again plus g of I is 2, s 3 comma 4 minus j value is 4. We know four minus 4, 3. Like that you have to substitute. While we solving the problem, here g of 2 comma 3 minimum value is 14. So we have to substitute g of 2 comma 3 is equal to 14. Like that you have to solve the problem regarding to the parent node 2, parent node 3 and parent node 4 also. Here we find that parent node 2, the chain nodes are 3 and 4. That's here I mentioned that mod s is equal to 2 nodes. Like that you should have to find for the parent node 3 and parent node 4 also. And like that you should have to solve mod s is equal to 1 and mod s is equal to 2. Now we are going to solve the mod s is equal to 3. Mod s is equal to 3 means the 3 children. Here parent node is 1, the parent node contains 3 children, that the parent node is 1. So we should have to mention the formula by I is equal to 1 and j is equal to 1 comma 2 comma 3. This is the children nodes and this is the parent node. So substitute the g of I 1, j is 1 comma 2 comma 3. By this we can form c of 1, 2, 3, 4. So we can form column number 1 with 2 and column number 1 with 3 and column number 1 with 4. So here I am forming C1 2 plus G of, here I is I 1, S is 2 minus J. Minus J is 2. So again I am forming the column number 1 with 3. So C13 plus Z of I is 1 and again 2 comma 3 comma 4 minus, and again these can be formed with column number 1 4. So C14 plus Z of minus 4. By solving this, we can get the minimum value nearly 35. By solving this, we get 35, 40 and 42. Here the minimum value is 35. You should have to mention that column 1, 2 is row number 1 and column number 3. So row number 1 and column number 3 value is 15. So you should have to write it 15. And column row number 1 and column number 3. Here the value is 15. And row number 1, column number 4, the value is 20. You should have to write the values according to your adjacency matrix. Like mentioned, we have to find these values in above mod S1 and mod S2. So we have to substitute these values, and according to this we can get a minimum value like that. And you should have to find the minimum value for mod S is equal to 1 and mod S is equal to 2 and mod S is equal to 3. We should have to find all the minimum values and traveling distance by using traveling salesperson programming. So, did you get some idea according to this problem? Yes. Is there any doubts?
No.
Is there one of the persons? Grishma. Grishma, did you get understand on this basic problem?
Yeah.
I mentioned the formula, and I mentioned that before starting the session, the number of elements is represented as something I told you. What's that? And it will be represented as like a modulus. What's the number of elements which were taken in the adjacency matrix that can be considered as represented as something I told you. What the elements can be represented as? Huh? And Tej. What is a traveling salesperson? I can tell the introduction briefly about this traveling salesperson program now. What's the traveling basic? What you understand about it?
It is a dynamic programming and it says about the distance and we can find the distance of the shortest path of the person while traveling.
Nikita. Here I mentioned that this is mainly based on dynamic programming by using, I told you something now, by using which? Yes, it is mainly using dynamic programming by bit marketing. Okay, that's the main point why you solve this problem. Meena. And here here I mentioned the adjacency matrix. Mod S is equal to 0. What's the formula which I mentioned to solve this problem?
C I equals 0 S minus J.
There is no doubt, no, regarding to this problem. Thank you.